Standard form looks like simple science fiction, but examiners use it to set brutal traps that easily destroy a perfect exam score. If you write 12 times 10 to the power of 9 as your final answer, you will instantly score 0 marks. Watch this. Imagine you are the pilot of a futuristic intergalactic spaceship, navigating across the vast dark universe to discover completely unknown distant galaxies. To chart your course, you must calculate massive distances, traveling millions of light years across the universe in a single hyperspace jump. But suddenly, the ship sensors detect an incredibly tiny microscopic alien virus rapidly spreading across the smooth glass of the main control console. You need one mathematical system to measure the massive distance of the galaxy and the incredibly tiny size of the microscopic virus perfectly. In math, this universal system is called standard form. We write it as a multiplied by 10 to the power of n. Here is the absolute unbreakable rule. The value of a must be greater than or equal to 1 and strictly less than 10. N is the index, which must be a whole integer. It controls the scale. Let us write 32,400 safely. We must make the first number fit between 1 and 10. We place a decimal point perfectly between the 3 and the 2. This gives us 3.24. Now count how many times we must multiply by 10 to get back to the original. The decimal jumps exactly 4 places to the right, so we write 3.24 multiplied by 10 to the power of 4. For microscopic numbers like 0.00000324, the process flips. Put the decimal after the first 3. We get 3.24 again, but this time, count how many places the decimal must jump left to restore the zeros. It jumps exactly 5 spaces. Because we are dividing by 10, the index is negative, 10 to the power of negative 5. Multiply 3 times 10 to the power of 112 by 4 times 10 to the 235. First, multiply the ordinary numbers together. 3 multiplied by 4 equals exactly 12. We write 12 down on the screen immediately. Next, use the laws of indices. Since the bases are exactly 10, we just add the powers. 112 plus 235. This equals exactly 347. So we have 12 multiplied by 10 to the power of 347. Here is the deadliest examiner trap. 12 is greater than 10. If you leave this as your final answer, you get 0 marks. We must convert 12 into standard form. It becomes 1.2 multiplied by 10 to the power of 1. Write this clearly. Now multiply it back with the original 10 to the power of 347. We simply add the powers together again. The final A-star answer is 1.2 multiplied by 10 to the power of 348. Perfect marks. 45 times 10 to the negative 123, divided by 0.9 times 10 to the positive 105. Write it as a giant fraction. First, divide 45 by 0.9. This simplifies perfectly to the ordinary number 50. Next, divide the powers of 10. We must strictly subtract the indices. Negative 123 minus 105. This creates an incredibly small negative index, 10 to the power of negative 228. Put it all together carefully. We get 50 multiplied by 10 to the negative 228. But remember the trap. 50 is way too large. Convert 50 into 5 multiplied by 10 to the power of 1. Now add this to the massive negative index. Positive 1 plus negative 228 is negative 227. The final perfectly adjusted answer is locked in. The final answer is 5 multiplied by 10 to the power of negative 227. Let us move to addition. Subtracting standard form is brutal. Subtract 2 times 10 to the 148 from 4 times 10 to the 150. Another trap. You cannot just subtract the ordinary numbers if the powers of 10 do not match perfectly. It is mathematically illegal. We must rewrite the larger power of 10 to match the smaller one. Break apart 10 to the power of 150. We write it as 10 squared, multiplied by 10 to the power of 148. The powers perfectly match up now. Multiply the 4 by that 10 squared. 4 times 100 equals 400. Our first term is now beautifully transformed. We have 400 times 10 to the 148 minus 2 times 10 to the 148. Now just subtract. 400 minus 2 leaves us with 398. Keep the matching power of 10 exactly the same. We have 398 multiplied by 10 to the 148. Apply the final check. Is it in standard form? No, it is way too large. Convert it to 3.98 multiplied by 10 squared. Then add the indices back together. 2 plus 148 equals 150. The final answer is 3.98 times 10 to the 150. 5 times 10 to the 20 times 6 times 10 to the n equals 3 times 10 to the 33. 5 times 6 is 30. Add the indices. We get 30 multiplied by 10 to the power of 20 plus n. This equals 3 times 10 to the 33. We must change the 30 into a 3 to make both sides match perfectly. Divide 30 by 10 to get 3. To balance this, increase the power by 1. The index becomes 21 plus n. Both sides match. 3 equals 3, so 21 plus n must strictly equal 33. Subtract 21 from both sides. N is equal to 12. Let us recap standard form. The front number must always be between 1 and exactly less than 10. Always match the powers of 10 before adding or subtracting. And always double-check your final answer size to avoid the examiner trap. Follow GetYourTutors for more Cambridge Math Masterclasses and guarantee your perfect A-star grade on your upcoming exam today.